Welcome back after the long summer break. We're going to be back to one a month from now on. I hope you all had a good summer. Thank you very much, Facebook, for hosting us again. You're fantastic hosts, especially to Camelia and Tony. Next month's React Meetup is going to be at Bloomberg. And watch your notifications on Meetup because the tickets are going to be on Eventbrite instead. They're still free. But yeah, they'll be on Eventbrite for next month at Bloomberg, and then we'll be back here after that. Big night tonight. Welcome to Nick Schrock, who's going to be talking to us. He's one of the creators of GraphQL, so it's very exciting from Facebook. So it's very exciting that he's come to talk to us, and I'm really excited about this because this is awesome technology. And Red Badger's hiring. I have to say that I'm going to be emailing you all individually. So if you want a cool job, it's a great tech strong company, then consultancy, then come and talk to us. Okay, Nick, thank you very much.
Well, hello everyone. Thank you for coming. We got the pizza. You guys really like pizza. Next time I'll remember to ask for the security detail. Anyway, thanks for having me, and thanks for Red Badge for organizing this. So, here to talk about GraphQL and calling it a horizontal platform, which hopefully by the end of the talk will make sense. So, I'd first like to, well, first of all, my name's Nick Schrock, and I'm an engineer at Facebook. I've been there for about 6.5 years, and I am one of the co-creators, along with a couple of engineers, of GraphQL. So, GraphQL is a language for client applications to specify their data fetching requirements. And it's a way to think about data. And it's a way that we think is really congruent with the way that product engineers think about constructing their applications. And this is a real technology. If you are an iOS developer or an Android developer and you're working on the main Facebook application, GraphQL is the way that you use to interact with our server-side data. It is used to power the entire surface area of those apps. So I want to start about kind of where GraphQL came from. So the story starts about 4 years ago in 2011 when Facebook really got serious about mobile. So before 2011, Facebook actually did have mobile applications, but they were kind of an afterthought. In fact, our iOS app was basically written by one guy, Joe Hewitt. And he kind of was just on his own doing his thing. And we maybe had one or two other engineers that helped him, but it was really an afterthought at the company. And because it was an afterthought, the mobile apps just fell way behind. And we did not have feature parity. So we got a ton of feedback from customers that they want all the features of the main site. Well, Facebook is a web company. The web is very deep in our bones. It's kind of how we started. And our culture is actually really intermixed with the culture of web technology. So when we started building our new apps that were going to be feature parity, we decided to go HTML5 in a web view. And this we're really able to leverage our existing culture and our existing operational capability, our existing code base, and all the rest of it. And we thought we could provide kind of the parts of native that we needed, like notifications and other features, while preserving that investment in culture. And this did actually move us from a company that was a mobile afterthought to mobile first. We did now have web applications, and then we had mobile applications that had feature parity. And that was a big step forward. There was an issue with this strategy, though, in that the apps ended up being unbelievably awful, which was a minor downside. Mobile web browsers just really couldn't handle either the way that we were coding or the complexity of our applications. I mean, you probably remember this if you're a Facebook user circa 2002 through 2011. It was terrible, right? It would crash all the time. The scrolling was terrible. Startup was terrible. Everything was terrible, except for feature parity. So in late 2011, we embarked on project to actually rebuild our iOS application from scratch. Literally, one of the people we hired from Apple clicked File, New Project. And we started from there. And really what this was, it was a from-scratch rewrite of our mobile application, but it was a de facto re-architecture of our entire software stack. And that's because we fundamentally changed from an HTML5 app where you delivered web server to a front-end client to an app server that delivered just data. And all of the presentation logic, all of the UI was now embedded on the client, right? You can kind of think of it as this altered the center of gravity in terms of our product engineering from the server to the client. It is a huge and gut-wrenching shift in culture. But this really needed to happen. This really needed to happen. The mobile revolution was real. This is one of the biggest shifts in consumer technology of all time. And really the inability of technology companies to adjust to these type of shifts has kind of been a surefire way to consign them to irrelevance or the grave. So this is a really big deal for the company. So we started off with a REST API. So I'm going to do a little aside. There's a lot of controversy about what a REST API is and isn't. What I will say is that when we say REST, I'm not really interested in a technical, pedantic definition of what REST is. I'm talking about, this is just straight up politician's dodge. I am talking about systems that self-identify as REST. And you know what I'm talking about. They're HTTP requests that get stuff. That's a technical definition. And this is one of my favorite images that's come up in the last week. And it's kind of this like poorly defined technology that no one knows what it is. But you know it when you see it, I think is the current definition. So that's one thing. So effectively, we started out coding REST endpoints, right? And so the definition that I will say is that when I encounter a system where you effectively fetch resources by URL, and then you need to navigate to other resources via URLs that are embedded in that document, that's what I am basically defining as REST. And you run into those limitations, right? Because you end up doing multiple round trips to the server, and if you're in a mobile application, and say you're in rural India, and it takes 2 seconds just to get to the edge of the internet, and you have a 25% failure rate, this is not an acceptable way to architect an application. So what do you end up doing, right? You end up, for the important interactions, you basically build completely custom endpoints that deliver exactly the data you need. And then for the interactions that are less important, you end up using these kind of sequence of requests, right? So any REST application I have seen ends up being this spectrum of single type endpoints all the way to super custom endpoints for the key interactions in the app. I guess like the fancy term for those custom endpoints in today's du jour is microservices. It's generally just a piece of code that does stuff and returns you JSON. And kind of more profoundly, well, not profound, but kind of when you step back, these APIs that are URL-based or kind of SQL or table-based are not really the way that most product developers think about data. Product developers think generally more in terms of graphs. You are generally building hierarchical views of data, and you are generally dealing with data that's isomorphic to that view, right? You're generally dealing with hierarchies of data. I mean, that's how I think of data in general. And that's how at least the product developers at Facebook have, and we found that that's how product developers in a lot of places think about data. It's just much more congruent with the way you think about it. And that's kind of the genesis of GraphQL. It's a query language that aligns the data fetching language with the way that product developers think about data. And this seemed to work. So a few months after its conception, we launched the iPhone app. And that iOS app was just a little over 3 years ago. And it made the huge jump from like terribly awful to like passable, which was like a huge leap in our customer experience. But it has gotten better over time. And that iOS app still works today, as far as I know. And that's still powered by GraphQL. So today, this number might be a little out of date, but this is a really real system. We serve about 260 billion GraphQL requests per day to power our apps. And so we have deployed this at scale. And we have, I think, over 10,000 types in our schema and hundreds of thousands of fields. So it really does have a wide surface area and is used a lot. So what am I actually talking? What am I actually talking about here? I think that's a fair question. So I like to introduce these things by example. So this is kind of the hello world of a GraphQL query. And at its most basic level, what we're doing is we're uploading a string to the server. The server is parsing it, executing it, and returning a result back to you. Right? It's like very simple definition. So what you look is that this query looks kind of like JSON. Right? It has a hierarchical structure, curly braces, and then it has fields that have subfields. Right? When you do a query, you get a JSON result that's very similar to the query. But you have more capabilities than that, right? So here you can actually parameterize something with a parameter. So this is still getting the same information, but instead we're fetching it by ID. And again, that returns my information. You can also go deeper into these object hierarchies. Right? So here we're creating for me, my name, and then a profile pic, and then that has subfields as well. And in GraphQL, you have to go all the way down to the scalars. There's never like an implicit filling out of all the sub-objects. And here, you get what you would expect. My name, width and height of a profile picture, and a CDN URL that points to the actual profile picture. You can parameterize fields all the way down. Right? So here, profile pic allows you to pass in a size, and therefore, instead of size 50, you get size 300 in a different CDN URL. A logical question to ask is, what if I want both sizes? Well, and the problem is there'd be a collision between the keys, right? You can't have two keys named profile pic. So we have this feature called aliasing. And you can rename different keys to be different things. So here, you have little pic and big pic, and they correspond to the two different return values. So where this gets more interesting, actually, is when you're descending down connections. Right? So in this query, I'm asking for me, my name, all of my friends, and all of their names. Right? And you can arbitrarily go down your entire graph. So here, we're requesting my friends and all the events that they say attend. And so it's actually a really, really natural way to kind of express the hierarchical data that you want. Because you just say declaratively exactly what you want, and you get a response that looks exactly like the query. It ends up feeling really, really natural. So what are some of the core, beyond just the language, what are some of the core principles? So like we said before, we think it's a really elegant mental model for developers. But there's other key parts as well. So at the core of GraphQL is a type system. So every GraphQL server exposes an application-specific schema to those who consume it. And that means that at every step along the way in a query, you know exactly what type you have at each specific node. And then you know exactly what type of fields you can query. It's a strongly typed. Another programming language community, strongly typed query language makes a lot of sense. But in JavaScript, it's like this whole new world of strong typing, right? But as you descend down the query, different types are in context. So we start at the root. So with every GraphQL schema, there is a root type that is in context that determines what root fields you can start at. You can kind of think of it as the entire graph of data of your application. The root fields say what nodes you can start at, if that makes sense. So we have me and user, they're both type user. So we descend down to me, and now there's a set of fields that are available. So this is actually somewhat interesting because it explains some of the concepts of GraphQL. So you'll notice that we don't just pass in a string into the order by here. See, it's order by importance. And that's for a very specific reason. At Facebook, we use GraphQL to, the server explicitly whitelists what you're allowed to order something by. Because we have like 13 bajillion servers or whatever, which means that we have tons of user shards, mean that maintaining indexes for any piece of data is really expensive and needs to be an explicit decision. So what that enum is saying, look, I'm willing to provide you an ordering by first name or last name, but you can't do anything else because we can't guarantee that it'll be scalable across 1 billion users. And then you have this importance thing. So importance is actually a field that we do not return. So when you're typing on Facebook and a type ahead comes up, it always happens to know who you've been talking to a lot. Well, We have an entire team that maintains that. It has big data and machine learning and all the rest of it. But this ordering is purely done in software, right? We get a list of users, we get their scores from a different backend, and then we order it. But we actually don't return the score, right? It's like this kind of virtualized ordering. So this is not a database, right? This is backed by arbitrary code, which I'll save probably 10 times in the rest of the presentation. Then as you descend down this graph, right, you have profile picture and context with height URL. We're going back to friends. You're at the same exact user object, right? This is a coherent type system. And then we select different stuff on the users at that level of the query. In particular, we have names and events, and then we can get down to an event, and those are the things that are available on an event. So at each step along the way, right, we have exactly a set of fields that we can query, and each node has a specific type. So this relationship, being able to specify the queries in the client, changes the client-server relationship. So without this system and more of a just request object by ID system, you have this dynamic, right, where you ask for a specific model, and then you return a specific set of data. And as you iterate your application, let's say every time that you add new data to a specific view, you generally have to add new data to that specific model. And then most REST systems don't allow you to selectively request columns. And therefore, you kind of just monotonically increase the size of the payload over time. And you're iterating both in lockstep, right? Models and views, models and views, models in the server, views in the client. GraphQL changes that dynamic. Instead, via the type system, the server expresses the possibilities of what you can query across the entire graph of your application, right? And it does that via the type system. And then the client specifies its requirements via a specific GraphQL query. And with this, instead, as you iterate your specific UIs, as long as that data already exists somewhere in the system, you're iterating your views and your models on the client. So it removes a dimension of client-server coupling that's actually pretty undesirable. And this strategy is actually really successful for Facebook. So we have basically a single GraphQL schema, and it powers a wide variety of applications. You think of just the main Facebook app, but there's also Messenger. If you work on ads, there are ad-specific apps. There's another app for managing a page. We have actually lots of apps. They're all powered by GraphQL. And then for each one of these apps, there are tons of versions in production. Right? We generally have every 2 weeks we release a new version of the app. And then you multiply that across, supporting it across years, across many different applications. You're talking about supporting thousands of live versions of our clients in the wild. And our stated contract is that they'll work for at least 2 years. In reality, we support them forever. And as far as I know, they all work, so it must be working perfectly. That was a joke. Yeah, you can laugh. So another important concept in GraphQL is composition. So as your products that you build become more complex, your GraphQL queries become more complex. The most extreme example is our feed product. Feed is our most complicated and our most business-critical application, and it was GraphQL's initial use case. The feed query, I believe, has about 10 to 20,000 leaf fields in its GraphQL query. It is a massive, massive query. And it'd be ridiculous to have that all in one file or something. So we provide a unit of decomposition, and we call it the fragment. So what it allows you to symbolically refer to a subquery. So you can just name a specific, we call it fragment, that is on a specific type, and then you can refer to it by reference. And this primitive is as important to GraphQL as like functions are to a standard programming language. And typically, the way this plays out, for instance, something like Relay, is that you have a one-to-one correspondence between view components and the fragment components. And the trees of fragments generally mirror the trees of views, broadly speaking. At least they're shaped similarly. So the fragments are just a critical abstraction for modeling GraphQL within the context of UI libraries. So another one of its principles is that GraphQL is backed by arbitrary code. It is not a storage engine. It's not a query language for a graph database. Okay, let me repeat that. It's not a query language for a graph database. It is a query language over your application's graph, meaning your application's data model, which is defined in code. We get a lot of feedback about the name, that it's confusing because people think it's for a graph database. Well, the goose is kind of cooked on that one. And if the name confuses you, I apologize. But think about it this way. When JavaScript came out, that name made absolutely zero sense. Andreessen just made up the name for branding purposes because Java was cool, even though it had nothing to do with Java. You know what? We all got used to it, and everything's fine. And we all still love JavaScript, don't we? So the name's sticking. I apologize. But anyway, so let's talk about this property that's backed by arbitrary code. Why was that important? Well, our initial use case was feed. As I said, feed is an extraordinarily complicated product. It's backed by a feed ranking engine, which again is another like big data, machine learning, insert buzzword here, blah, blah, blah. But it's a really complicated system that effectively returns a ranked ordered set of IDs, right? And there's like an ads auction, and it's shockingly complicated, actually. In addition to that, we have our sharded user databases, which contain all the human readable information. And even some of that isn't human readable, because some of it's like, say, a CDN URL. And then you have a link image cache, and wow, that's not what it looks like on my slide. Well, anyway, let's move past it. And in order to orchestrate it, right, we have a layer of application code that knows how to orchestrate between all these services. This is Facebook's mammoth PHP codebase. And the idea of ditching that or rewriting it or anything like that was just absurd, right? But we wanted to do a structured query language, so we overlay GraphQL on top of our existing application code. So that means, again, that GraphQL is not a storage engine, right? GraphQL queries over arbitrary code, which gives it the nice properties is that GraphQL can query over your existing code, right? Adopting GraphQL does not mean a from scratch rewrite of your system. What it does require is adapting your code to the GraphQL front end. And that's what our reference implementation in GraphQL JS provides, as well as implementations in other languages. So what do I mean by that? So this mapping between your code and GraphQL is done via the GraphQL type system. So effectively, as a developer, you become as a server-side developer, we like to call them GraphQL type designers. And your job is to map externally facing GraphQL types to your application code. So what does that look like? Well, here, let's imagine we have a type, name, profile pic, and friends. You could have your basic types or your basic fields that just return just a straight property out of the object. That's pretty simple, right? But then let's make this more complicated. Let's say we want a profile picture. Well, in order to construct a CDN URL, you need some code to mash some strings together. You might have to poke at some configuration to decide what CDN to go at. You need code, right? You need code in order to do this. So the field maps to a function. Right? And actually, functions are kind of the mental model of how you should view fields. It's like a thing that you can pass things to, and you get back another thing. That's a really precise definition of a function. These things get more complex, right? So in the JavaScript engine, you can actually return promises. Right? So this function actually returns an array of promises to a component that we call the executor. And you can think concretely, the executor is a thing that calls promise.all on like these n promises and does that orchestration. So this is actually a really, we talk all the time about the benefits of using GraphQL on the client because that's kind of the end consumer. But I think it actually has a nice structuring. It provides nice constraints on the server side because you can end up dividing your application to little asynchronous chunks, and a lot of the orchestration is done by the centralized component. I don't know about you, but how should I put this? The amount of time, the less amount of time I spend dealing with the Promise API lowers my lifetime spend on therapy. It's a very difficult API to deal with, in my opinion. So the fact that there's a centralized component that handles a lot of the more complicated error handling things in a generic way is really, really positive. So the type system is useful in terms of being able to make guarantees that if you send up a string and a GraphQL query that it is a well-formed query that has valid fields all the way down. But it ends up being even more powerful than that once you export that type system from the client. So when we were designing this thing, we were like, well, we need a nice structured query language to query data and get it back so that tooling can consume it. So we're like, oh yeah, we know a thing that can do that. So you can actually query a type system with a schema of a particular GraphQL application using GraphQL itself, right? We're all very proud of ourselves for this little self-retrofit loop. This is like top 10 nerd catnip, right? So every single GraphQL server has to, oh, hey, we're getting intimate now. Can we get candlelight? All right. So every single GraphQL server has to expose this root field called dunder schema. We prefix things that are predefined in the system with 2 underscores. And this actually returns the type system result. So this would query the actual, and I'll show you this once I demo GraphQL, but this actually queries and returns information about the type system itself. And we call this introspection, and what it really is a platform for building tools. And it really is one of the things that really unleashes the power of the system. So you could build documentation browsers. I'll demonstrate that in a second. You could imagine building code generation systems to model on the client. I mean, this is standard for any sort of IDL language and any sort of strongly, protocol buffers or JSON schema, anything like this. But it allows you to build code generation in any language. You could do one in JavaScript with Flow. Another thing before I hop into GraphQL is mutations. So this is actually our fault. We haven't communicated this very well, but GraphQL is not a read-only system. We focus on the read case a lot because it demos well, and it's kind of the first use case we thought of, but this is actually an entire system for data management. So all the mutations, and certainly all new mutations in the Facebook application are done through GraphQL mutations. So how do we evolve from that? So let's start off with a GraphQL query. This is a standard read. And me is like an entry point into this, into the application. There we go. And again, you can like query things. This is another different root field, again, where the read side of this defines where you can start the query. And this is the unadorned open curly brace is just a shorthand for the query keyword, because it's like the most common use case. But we have another keyword, and that's mutation. Okay? You can send up a mutation that mutates something, and then you query the results that happened after the mutation. So what does that look like? So this is actually very aligned with the philosophy of Flux, in that effectively GraphQL exposes a list of centralized mutations, and each one of these mutations just maps to a function that can do whatever it wants. Right? So here we have a mutation called like story, which takes a story ID, right, and likes it. Okay. But then generally what you need to do with a UI, right, is you mutate a story, but then you know that based on what you actually did with that mutation, you have to re-query certain information that might have been updated. And typically, you only know that on a per view basis, right? So there's 2 pieces of information you need to know, right? What are you displaying, and what could have possibly changed? And based on that information, you union both of those, and that's what you query. So here, we know that the things that could change will be the like count, and did the viewer like it or not? So this says, mutate this story, and then after the mutation, query the story and get this set of information about it. So this can apply to, say, CRUD operations, like create and update, standard things. And you can imagine libraries that make it very easy to create this. And then also non-CRUD operations, just arbitrary business logic. Again, if you're using Flux or one of the 355 implementations of Flux, you know that it's effectively a switch statement that goes to a function, right? It's an idea to centralize mutation instead of doing kind of what it isn't. It specifically is not a system where you new up an object and like set something, and save, and then you have to deal with change sets and all this stuff. So all this stuff kind of fits together. So that is mutations. Okay. So what I'm going to go through next is kind of how you would transition from a REST style or REST-ish API to GraphQL. And I'm going to do it using the Star Wars API as an example. So this is swappy.co. It's a publicly accessible REST API that's kind of supposed to be a showcase of REST best practices. So it kind of behaves like normal REST APIs, right? You go to it, you're browsing around a website which has all the documentation. You have a little console where you can practice your requests. And then there's lists of documentation with all this stuff. And then in your results, in order to traverse to connected objects in the graph, you get URLs, right? And then you typically have to do round trips in order to get subsequent. So that's the world that you're used to. Now we'll see see how GraphQL looks in this. I know, it's a whole thing. So this is graphical. So you know the world of REST, where you go to an API, and you're browsing around a website, then you're looking at the documentation, and then you're looking at, and there's generally, it's pretty tool poor. Well, look at the world that we live in. You start typing things, and then, oh, it's actually, this is new. The OMG GraphQL is actually what gets printed when a query is executed, and they just updated this so it queries on every keystroke, so it's a little, but here you can see all this stuff is popping up, right? Actually, we're gonna hide this for a second. I'll replace it with a picture of a pizza, how about that? So here, and look, all this pops up, there's documentation in line, and then you can execute a query and get stuff. We also have a documentation browser. This is new. So you can click around. Oh, here's our root type. Here are all the fields available at the root. Let's go to a Starship. And this is actually, we should have the documentation inline in the previous screen. I'll talk to the guys about that. But you can kind of see how nice this is. So let's imagine that we're traversing. Jesus. We're getting all the, so right now we're just going down, right, and getting all the pilots that it's obnoxious. One second. All right. You go away. So here, what's happening on the left-hand side is it's showing you all the requests that would have needed to happen in order to replicate this using a REST API, right? So this is literally, so full disclosure, we scraped the entire graph of the swappy. So this is all executing locally because demos and you don't want to rely on Wi-Fi, right? Someone could be like watching Netflix back there. But as you can see, this is in one round trip doing what you would have had to do many, many times. Let's see here. So we do this example. So let's get manufacturers. Oh, I need to type better. So get the manufacturers here. So this is actually an interesting case here because, oh, we did that again. Oh, well. I need some design help on that one. So in the original API, there's a manufacturer field, but if you actually read it, you're like, the manufacturer of this Starship, comma separated if more than one. So you've seen this in REST API, you're like, oh God, now I need to on every single client, I need to split on comma, and then there's probably some weird cases where sometimes the comma doesn't have a string in it. You know exactly, you've dealt with this dozens of times, you've dealt with a wide variety of systems. So what's one nice aspect about GraphQL being the fields being backed by arbitrary code is that you can fix this in one spot, right? So literally as we're building, this is open sourced, our swappy GraphQL wrapper. As we were building this, we're like, whoa, that's weird. How about instead we return a list of things and then parse it for you once on the server side and return it. Now all different clients, whether they be Relay on the web, iOS, Android, or whomever, right, deals with a list of things because it's returning a list of things. And then you can name it manufacturers instead of manufacturer, which is a huge advance in usability. So instead you get back an array of stuff, right? And it seems like a little example, but this stuff adds up over time, right? And this stuff matters. So let's go back, do some more demo things. It's fun. And you are gonna be hidden, so we're not distracted. And then, what's really nice about this is that you can just end up going arbitrarily deep here. So get the name of the home world of some pilot. What else? What other information is here? Oh, here's this nice, This is the part of the system. If you're like struggling to convince someone at work that this is a good idea, like just show them graphical. Be like, do you want this? Like, and they always say yes. It's been my most successful scheme to get people to like this. Okay. And then you can kind of demonstrate how fragments work, right? So let's imagine we wanted a world fragment. And then look, type heads everywhere, right? It's amazing. Not that, though. So we wanted name, gravity. Another nice thing, look here, it tells you exactly what's wrong. Oh, it's never used. Maybe you should use it. So the errors are all pretty nice in the system as well. Then we can say, oh, they still haven't added that type of head. All right, and then that works, right? And you can see how you could like build up these fragments over time. All right. So this architecture is what I call, or what we call a REST polyfill, meaning this is a really good strategy for introducing it to your organization. Because, I know how this goes. The JavaScript guy or person goes up, it's like, hey, back-end person, we should re-architect our entire application because I like this new trendy technology some hipster told me about. And it's like, that's cute. How about we don't do that? Instead, what you can do, right, with this REST polyfill is you can just write a pretty simple GraphQL server, plop it in your data center, and then just have it interact with the REST endpoint or the REST server, right? You don't even touch the other thing. And then you can just express your own type system, and then you point GraphQL at that bad boy, start typing, and things magically start appearing. And all of a sudden, you're doing one round trip with your mobile clients to your servers. And all your REST interactions are within your data center. And this is much better than what was before. And then it kind of starts to like sell the system implicitly. And once your client developers all are into this stuff, then you can start kind of like moving the world. Because like I said, the center of gravity of engineering has really been shifting more and more to the client. But that shouldn't be the long-term architecture. Once you've really bet big on GraphQL, it really does pay dividends to kind of do the full Monty, so to speak, and build the whole server. So that is our intro to GraphQL. What started out as a way to build our native newsfeed has really turned in a way we build almost all of our applications. So when we built it 3 years ago, we really didn't know how critical that it would become to Facebook. We had a notion that it could be, but we certainly didn't know that it could be used outside of Facebook. And we released GraphQL to the public in early July in technical preview form, and it really has been truly overwhelming, the positive response that we've gotten. We kind of didn't know how it would land, because when you've been working on technology inside of a company for a long time, and you don't have that many touch points with the outside, you're not sure, you can never be 100% sure that the inmates aren't running the asylum, so to speak. And so we've been really gratified to see the response on the outside. So we've released a bunch of stuff, right? We have the reference implementation. We have our specification, which we wrote. By the way, I have a new respect for those who write these formal specifications. If I die never having to do that again, I'll be perfectly content with that. They're graphical. Also, GraphQL Relay, which is a set of software that makes it easier to build Relay-compliant GraphQL schemas. We've released Express GraphQL, which is an HTTP server, libGraphQL parser, which is a C++ parser, which can be embedded into other scripting languages, and this one I just showed you, Swappy. But what we're really excited about are the external projects. Right? So we have a really high-quality implementation built in Ruby, another one in Java, and then there's Sangria, which is a implementation that's built in Scala. This guy is out of his mind. So he actually, we would submit diffs to our spec, and then he would submit change PRs to his repo before we could do it to JS, which was very impressive. Also, it's like his website's better than ours and all this stuff. It's really impressive, actually. It's like, oh man. Reindex.io is here. Vil's here. They're a startup building GraphQL as a service, and then from Red Badger, they're working on, I guess, working on building the next version of the homepage of the Financial Times using GraphQL, but we're not sure if that's going to land. And then we have GraphQL.org, kind of where we're centralizing all this stuff and doing blog posts and things of that nature. But what I want to talk about next, actually, is kind of to step back from GraphQL and talk about Facebook's open source efforts in general. Because looking at it from the outside, I think it could be somewhat confusing in that Facebook is releasing open source technologies at a pretty frenetic pace, right? Both broadly, but also specifically stuff that's relevant to this audience, right? So just things to name: GraphQL, Flow, which is our gradual typing system in JS. You have Nuclide, which is our IDE that targets all these technologies. You have React, React Native, Relay. And while each one of these projects is useful in and of itself, we're not doing this blindly. All this stuff does fit. It fits together. Another way of saying that is the whole is greater than the sum of the parts. Right? So what is it exactly that we're doing? So let's step back and think about broadly where we are as an industry in terms of what I mentioned before, which is mobile revolution. And the mobile revolution is a titanic, epic shift in consumer computing, right? In a relatively short amount of time, billions of people on this planet have these supercomputers in their pocket. And they have enormous computing power, they have location information, they're connected to the internet. That means those consumers have access to communication, messaging, economic networks. It's really, in some aspects of life, just completely transforming the way people live, exploding entire new industries, changing the way people communicate with each other, et cetera. So this mobile revolution has been just a giant leap forward for consumers. For developers and for product organizations, this has been a huge step backwards, right? In terms of our ability to execute on software quickly and without organizational churn, right? And the real concrete manifestation of this is if you've ever gone from building a large website to building a large native client app, the transition is extraordinarily painful for a wide variety of reasons, both technologically and organizationally. So kind of how is it terrible, right? Well, one, you're going from open standards that no one controls except for standards committee to two dominant proprietary platforms of which you are a complete captive. They can do whatever they want. Instead of instant distribution of code, you have installed binaries, right? This was in particular for Facebook, gut-wrenching transition, because we're used to being able to push a mistake or a bug and then re-pushing a fix, and it's gone in 2 hours, right? Now, if you ship a bug to an installed client, it might stay around forever. Then you have to convince the customer to reinstall your app, which was crappy because of the bug you just installed, and it just dramatically reduces your velocity because the cost of mistakes are so much higher, right? In the days of the web, you pushed a bug, boom, and you immediately fix it, right? This world is way harder. Now, sitting hands-on keyboard, life is worth there too, right? How many of you have worked in a large iOS or Android code base? Okay, you should all be really thankful that you haven't had to do that. Because there's a certain nice thing about working in an interpreted environment with a scripting language where you can kind of stay in your flow state as you're coding, right? There's never these 1 minute breaks where you press compile and then you're like, Reddit is calling me. And then you read something and you're like, oh God, what was I doing? And it is just a much more hostile development environment. You're dealing with two proprietary stacks. They're only controlled by the companies. Trying to fix a bug in Xcode. Oh my God, are you kidding me? You have to go through this Apple process, and don't even get me started. Actually, I'm going to Apple to give this talk in 6 weeks. I might have to work on my messaging. And this is actually really profound or really important, is that you have to change everything about the way that you're structured. Because now platform is an input into the way you have to organize your team or your company. Right? When you're a website and you could deliver web technology to both iOS, Android, and mobile and desktop, you had one team. Or you could conceivably have one team. There are other companies that do other things. One product cycle, one PM, cross-platform technology, right? Now, you have to hire an Android person and an iOS person. And maybe, because engineers are expensive, one's in Berlin, one's in London, maybe they speak different languages, maybe they don't like each other. Then you have to hire another person so that they coordinate the changes between them. And that's just with like 2 people. Now imagine that with 100 people at a company like Facebook. And at Facebook, what you have to, with the big company problem, what do you have to do? You have to decide between organizing around products or around platforms. What I mean by that is that you could have an iOS team that's responsible delivering the iOS app, and an Android team that's responsible delivering the Android app. But then you have like a photos team in each one of those teams. So what happens there is that generally the technical execution of the application is better because there's like a single dictator who's in charge of maintaining quality in an app, but the product teams get out of sync. So then you're like, okay, let's organize it the other way. Let's have photos team, feed team, events team, and then they're responsible for delivering stuff within the 2 release vehicles. That synchronizes product roadmap, but then often the technical execution suffers. Facebook has, because there's no centralized arbiter to deal with kind of like abuse of global resources. You can add some mitigating things, but it's just way better to have a single team, single product. And at Facebook, we have this fundamental belief that tools, software, and abstractions can fundamentally change these entire higher order problems in terms of organizational dynamics. And we really think with React Native, GraphQL, and all the related technologies, we have the opportunity to kind of change the dynamics of mobile software development and client development across the industry. So React is core to this strategy. And on the face of it, especially when I'm talking to a non-React meetup, some people are asking, what does a JavaScript framework that is used to build UIs have to deal with some like epic, pretentious cross-platform mobile, blah, blah, blah? And I'm like, okay, that's a fair question. Well, React for us has been a spectacular success, as evidenced by this community and how many people, a React meetup can get to show up to talk about JavaScript. It's awesome. And there's a reason why React has been popular. React is opinionated. React has values. It's not a framework that says that everyone can come and do whatever they want. No. React has a specific opinion about the way that software should be structured, right? And you guys know all this. Programming should be functional whenever possible. You should pass around immutable data structures. Data flow should be one way. You should have declarative APIs. You should embed markup in your code, which that was always a fun one to explain to everyone. Rethinking best practices, this is kind of our mantra now. And it doesn't mean like ignoring best practices, but it means knowing and respecting best practices, but not being hostage to them, right? Things change over time. And I think embedding markup within code was kind of a singular example of like, actually it is a good idea if you do it right? It's not embedding markup, it's a DSL for building an AST. So, I guess that struck a chord over there. So React is this opinionated web framework. Okay, so how does this become a platform? Well, I think everyone in here knows the answer to this, and that is React Native, right? So React Native is this fairly thin JS runtime that can be used to build native iOS and Android applications, right? And you use the React programming model, you have instant feedback, no compile cycles, but importantly, it allows you to jump down and utilize proprietary technologies that customers expect, right? When I was talking about how difficult it is to deal with 2 different platforms within a product organization, well, there's a reason why we have to do it and contort ourselves to do it, and that's because that's what customers want. In the end, they are the boss, right? So we need to provide these proprietary capabilities that they expect. So we call this a horizontal opinionated platform. And so what that means is that there's unifying software, unifying abstractions, and unifying tools, but structured in a way that you can still use the proprietary capabilities that customers expect. And famously, this is kind of the motto of this. We are not chasing this write once, run anywhere unicorn that has been the kind of the pitfall of all pitfalls for these kind of grandiose software abstractions, right? Like this has happened again and again and again. The promise of Java, the promise of web, right? Sometimes you just need to do stuff that's platform specific because the underlying platforms are going to compete with each other to differentiate. It's just like a state of the world that proprietary platforms will be different enough that you need some custom code. And so we call this learn once, write anywhere. So learn once, meaning you learn these opinions, you learn the opinionated part of the platform that allows you to use the same tools, same abstractions, and then you can write it anywhere across the horizontal surface area, right? Meaning that you can write it in iOS and you can write it in Android. GraphQL is the exact same idea, but more applied to the server, right? It's a fairly thin layer of software that has a specification, right? It's an idea, it's an abstraction. And it can be backed by conceivably any programming language, even like, for God forbid, Visual Basic or something. And it can be backed by arbitrary storage engines, right? And you pick the language and storage engine that is most aligned with the application you're building. But you still have this unified API and abstraction that delivers to product engineers. Relay is kind of the perfect example of what happens when you buy into both sides of these platforms. Now, I haven't showed you any Relay code, and I haven't really talked about it, but Relay is probably the best product-facing API and abstraction I've ever seen. And the reason why is that it kind of goes all in and builds on the way that GraphQL and that React think about the world. And because you're betting on these horizontal platforms, you can write a single Relay application that with fairly minor tweaks, I'll go over that, can be targeted at iOS, Android, and the web, and it can be backed by any GraphQL server that abides by the GraphQL spec. Right? It's really broadly applicable. And this is working at Facebook. So we've released these apps, or we released an app called the Ads Manager. And this is a native application such that you can actually manage your ads and buy ads and create ads on the fly on your phone. We like to call it like the party interface to ads. So like you're at work all day and you build ads on your computer, and then you go to the after party after work and happy hour and you're like, oh my God, my ad's performing so well. So this is an extremely important interface for the social media types, trust me. But so we've able to build this in React Native. So originally, the ads team, they had budgeted 18 months to build the initial version of it. They thought they would need to hire 12 iOS engineers. I mean, they were just making up numbers, right? It's software. But it was going to be a massive investment. And so instead of that, the React Native team was like, instead of doing that, let's not do that. How about you take your existing team, which knows the React and JavaScript really well, and let's build this on React Native, and we'll help you out. And the way that worked was that 5 people, it ended up being 7, only one of them had any sort of like real like industrial strength iOS experience. They built this app in 5 months. And I don't know if you've dealt with ads data models in general, but they are really complicated. There's like campaigns and ad sets. The creation flows are really complicated. They have to work because it's like, this is business, It's not like, oh, I can't like this. It's like, I can't make money. And then they're like, oh, now we need to build an Android app. And we're like, well, we have React Native on Android now. And the same team built the Android app in 3 months. And the crazy thing about this is that they've been able to reuse 87% of their JavaScript. 87% of the code is reused. Now, if you're in software engineering management and you've had to deal with delivering native apps at the same time, and you're not like physically shaking, I don't know if you've fully absorbed the information which has been communicated at you. This is nuts, okay? This stuff is crazy. If we execute on this, this should completely revolutionize mobile development. And it's just like a really exciting time, React, GraphQL, and Relay are only part of the story. We're betting a lot on JavaScript. So, We actually recently hired Sebastian, who's the creator of Babel. I don't know if Sebastian's here. We're working on Flow, which is our gradual typing engine, and we're really massively investing in tools for this entire ecosystem. We're building an entire IDE to target this. And what's really fun is that we're doing this out in the open. Because I don't think we claim to have all the answers, and we get tons of ideas and help from this broader community. And I think really together we can all kind of get ourselves out of this mess we're in, where we're stuck waiting for Xcode and reading Reddit. And with that, thank you for coming, and I'll take whatever questions you have. So this is a new toy for me. This is a microphone you can throw. So if you raise your hand, you'll get this in your face. There we go.
Is there any tie-in between GraphQL and Apache Thrift?
Is there any tie between it?
Yeah.
Not specifically. I mean, they're both. Thrift is a strongly typed interface for effectively doing RPC, and it's similar to protobufs, sort of. But there's definitely no specific ties there. They're independent projects. Yep. What?
When you're talking about going all in on GraphQL, what's your kind of model for doing that? Are you trying to push everything towards that kind of GraphQL gateway layer, or are you using that for server-to-server communication within the data center?
Can you restate the first part of the question?
So you had an image on the screen of
Yeah.
kind of GraphQL from the client and then REST behind that. And
Yeah.
you're saying kind of try not to do that, commit to it. What kind of model to get rid of REST within the DC are you guys looking at?
Well, I mean, Facebook has that, right? Our internal structure is not that REST polyfill thing. So we just have a full native GraphQL engine, and it goes against our application code directly. Our GraphQL engine and our application code is in the same process. That should be the end state of any of these systems. The entire REST polyfill strategy is acknowledging the reality that introducing this type of technology into an organization is a process. Because you can't just based on one person's opinion, kind of be oh, we're re-architecting everything. You have to persuade your colleagues to do that. So some people are building GraphQL servers from scratch, where there's integrated from the get-go. Some people need to deal with existing systems that they cannot do serious surgery to, and therefore that integration layer of GraphQL is a really useful strategy for that. Questions? All right, I love that thing. That's awesome.
How do you deal with the schema changing over time?
So how to deal with the schema changing over time? So effectively, what you can do is you can only do things that are additive, right? So typically, what I didn't talk about is one of the aspects of our introspection system is that we actually have a Boolean that says, is this deprecated or not? And a deprecation reason. So let's say that you have a field called foo, and then you're well, no one should use that anymore. We should use foobar instead. So what you do is you deprecate foo and you add foobar. The existing clients will still be querying foo, but what the deprecation allows you to do is, for example, it won't show up in the type ahead in graphical. So much less likely for people to use it. And you kind of integrate that into tooling. And then if your clients die that access foo, you can delete it. But typically you just kind of structure your schema so that you're only doing things that are additive and then deprecating old things. So it doesn't magically solve backwards compatibility, but in our experience, it's made it much more manageable. And then, for example, internally, we sample our production queries and then log whenever a field is used. So we can kind of detect after the fact that, oh, someone actually made this field, but no one ever used it, so we can clean those up. Question? All right, I'm gonna go back here. Oh, okay.
Sorry about that. I was asking, how do you deal with data updates? So if you want to subscribe to a set of data that gets updated, do you have any thoughts on ways to integrate that into the protocol, or do you just rely on polling?
Yes. So 2 days ago, we published a blog post about our way we do subscriptions. So we haven't implemented this in the reference implementation yet, but that, effectively what we have released to the public is a better version of the GraphQL that existed in, say, early 2013. So we've added tons of stuff since then. We just haven't open sourced all of it yet. And one of those things is subscriptions. So part of the protocol that we will add is a subscription keyword where you upload a subscription, and then based on whenever that event happening, you can stream back down updates. So on your iOS app or Android app right now, if you're looking at, say, a story post and there's comments flying in and likes happen live, those are all done via GraphQL subscriptions. So look at that blog post. Yep.
Has anybody tried to DOS GraphQL servers, and does Facebook have any mitigation for large or malicious queries?
Yes. So we have, here, I can take that thing. Yeah, our site integrity team definitely has hooks for that to prevent people from scraping our graph. So it has been attempted, but we effectively can shut that down. We have like custom code that tracks that. But it's not built into the protocol. That would be an implementation-specific semantic. Because applications are different enough such that it's very difficult to build a generalized system to catch all the cases. And one of the nice things about it being backed by arbitrary code is that it's backed by arbitrary code, so you can do whatever you want. But it's certainly a risk. It's certainly something that needs to be managed. But anytime there's any client-specified query, there's always a risk of someone scraping your entire graph, subject to the privacy rules that are implemented in your system. Yeah. Yep.
Following from the last question, like he asked him, are there any like best practices for this mitigation?
So that's actually not my specific domain. We have an entire team called Site Integrity and Trust Engineering in general, filled with like lots of absurd geniuses who do all this stuff. So honestly, I don't know that much about that. But GraphQL is agnostic to specific anti-spam strategies.
One of the benefits of REST is that you can get HTTP caching, standard things like that. Do we give up that if we go with GraphQL?
So, oh wait, I don't need both. So it totally depends on your application, right? There is nothing preventing you from plopping in cacheability headers into HTTP requests. And one thing which we will release at some point, but it's not in the current reference implementation, is that at Facebook we use persisted queries, which means that at development time, we upload the query string, and you get back an ID, and then you can just send up an ID and parameters. And that is a short enough URL such that you can like easily have caching strategies around that. Now, we don't use it at all because how dynamic our data is and how much our privacy rule changes. If there is a data out on the internet which violates some of our privacy rules, like imagine like you block your friend, well, block a human you know on Facebook, therefore they no longer exist because they've said like hateful things to you. We need to like make that disappear from the site instantaneously. So we have like a 0-second TTL. So Facebook doesn't do any HTTP caching in that way, but it doesn't prevent other applications from doing it.
You've been talking a lot about moving from REST APIs to query. Like, how would you suggest you start that process? Because I understand that you can propose it, but when you've got a REST API and you want to start moving to a query one, how would you briefly go about that?
Sure. So I would build an independent service within the same data center and start to build up my GraphQL schema. And usually there's a one-to-one correspondence between a GraphQL type and a REST API that backs it. And if you actually look at the code for that swappy GraphQL, I think it's pretty straightforward what that would look like. So I would start with like, okay, I'm going to build a GraphQL schema with a single type that only gets the one endpoint, and then get that working. And then maybe build the type system so that you could express one of your views using a GraphQL query. See how that goes. And just like incrementally build up this like GraphQL wrapper over your REST API. And it's actually pretty straightforward to do it. I would highly recommend taking a peek at that swappy GraphQL code, and I think it'll be like straightforward. And that's it. So thank you all for coming. I'll be around.
Thanks, Nick. That was amazing. Wow. That's really good. Getting into GraphQL is actually easier than you think. I think one of the things that we're doing with some of our projects is putting GraphQL queries behind RESTful endpoints. So if you've got a client that already exists that consumes a RESTful API, put a GraphQL implementation that aggregates your microservices behind your RESTful API, and each RESTful endpoint just executes a GraphQL query against that backend. And then you can expose your GraphQL endpoint, and over time bring your clients towards GraphQL. So there's lots of ways of getting there, which is really cool. But I love that. Great. Okay, thank you very much. Thanks everybody for coming. There's more pizza, more beer. Stay around for chat. See you next month at Bloomberg. Thank you. Thank you, Facebook.